code. So obviously, this is part of the laser cutting project, but also it's important. Many of the templates that you're given are actually in DWG in AutoCAD, and you know very well AutoCAD. So you could either, imagine you have a template in AutoCAD. You can either send these guys by export selected as AutoCAD and laser cut project 1. Okay, say okay. And then you can open that one. So I'm going to zoom extend, which is the same. And here, your lines and the layers are exactly there with whatever color I gave them and with their name, cut 1, cut 2. So again, if you have a template in AutoCAD, let's say here, rectangle, just something like that with an offset with the layers, it would be the same. Just organize them inside of the template, change the layers to the colors they're assigning to you, and then deliver this DWG file to your laser cutting manager to laser cut. It's essentially the same thing. Which takes me to another way. What if you have elevations, and sections of the project you want to laser cut? Let's in, I don't know, polyline. I'll put it in a different. Let's imagine you have some elevations like that. Well, you can do the same. You just create a polyline around, and that will be the piece that you allocate in the template. So you can do all these things in AutoCAD if it's better for you, but it will be more orthographically. Maybe you can do this in 3D. I'm not an expert in 3D in AutoCAD, but I jumped into Rhino. But in 2D, if you have sections and plans, you can create a polyline around your plan and then just, place them, organize them after you place a code into the laser cutting template. That will work as well. If you imagine you have a template in Rhino, but you have sections and plans and so on in AutoCAD, you can also just basically save the AutoCAD file, and Rhino allows you to import directly any DWG. Just have to say it here, any compatible supported files. There is. So again, from AutoCAD to Rhino and Rhino to AutoCAD is very, very straightforward. It's an import condition of a DWG or an export selected as DWG, and you can open it. Now remember the 0,0 condition is very important. So, whatever this XY is located, that is a fundamental element to consider because that's where it's going. That's the way it's going to enter Rhino. Okay. AutoCAD 2D drawings, again, plans, sections, you can do the polylines, organize each of those polylines into the template, change the layers of that, send it to the laser cutting. You might want to take those polylines or those plans and sections, import them into Rhino, do the polylines in Rhino, organize them into the template in Rhino, send them to the laser cut. The laser cutting manager most probably has a template in Rhino, a template in AutoCAD, and probably has a template in Illustrator, which you can also very easily talk to from AutoCAD and from Rhino. So it's the same thing. As long as it's a vector-based program, most probably they have a template for those. If you have 2D information In AutoCAD, which is the normal thing, you will have, elevations and so on. But the tricky part is that's why I talked about it, when you have these type of faces, those elevations are tricky. You can always measure and then create a rectangle. But if it starts getting very complicated, the best thing is to go export in Rhino and rotate your thing until you get whatever drawings you need. No? And that's the reason why sometimes the 3D models are better for laser cutting, especially when there's some angles to consider. Okay. Yeah, I don't think we will talk again about how from Revit we go to Rhino and then we explode and we create a laser cutting from Revit, but we can't do that because we don't know Revit yet. Let me stop